For number 6, we are told that a 72.4 millihenry inductor is connected as in the figure to an AC generator with alternating EMF 45 volts. We're asked, what is the amplitude of the resulting alternating current if the frequency of the EMF is A 1.25 kilohertz and B 10 kilohertz? If we compare this to our figure in a previous example, number 5, we can see that the only difference is this part right here. So in number 5 we have a C, in number 6 we have an L, IL and V of L. So we're basically going to have this starting formula right here, except we're going to have a V of L and an X of L. So back at number 6, we can write all of the values that were given. So we're going to write this out and this out, and we're also going to write what we're given at A out. Our inductor, which is also our L, is equal to 72.4 millihenries. Our alternating EMF is also our V of L, and that's going to be equal to 45 volts. For part A, we make our kilohertz to be hertz. That way we can plug it into our formula, and our formula is going to be similar to the previous example. It's going to be I is equal to V of L over X of L, and X of L is going to equal 2 pi times the frequency times L. If we write this out, it's going to be V of L over 2 pi frequency L. So now we can plug in our known values, and we know all of them. We'll start with the denominator, and we're setting I equal to 2 pi times our frequency, and our given frequency is 1.25 times 10 cubed hertz. And lastly, our L is given up here, and that's going to be 72.4 microhenries. However, we need to convert this into henries, so this is going to be 72.4 times 10 negative 3h, and this is all underneath our V of L, which is our alternating EMF, which is 45 volts. If we plug this into our calculator, we are going to get approximately 0.08 amps. I is always in amps. There's our answer for part A. For part B, it's going to be the same thing. We're taking 10 kilohertz, and we're just going to replace it with this value, and that is going to return approximately 0.0099 amps. That is the answer for part B.